Hey y'all, it's Julie the nursing tutor. A student sent me these problems and they seem kind of tricky to me. And so I wanted to work them for you. These are not for sissies, I'll tell it like this. But if you'll just watch, I'm going to show you how to do it, okay? All right, so this one says, the order is for 4 TAS, 30 milligrams per kilogram. IV every 8 hours for an infection. The supply is 4 TAS 500 milligram vial labeled reconstitute with 5 milliliters of sterile water for injection. Look at here. The child weighs 65. I mean, they want a little bit of everything. And then calculate the dose ordered and how many milliliters will you draw up. All right, take a breath. You know, the first thing we got to do is to calculate that weight. That's the first thing we have to do. And so we're going to take 65, I ain't going to write that down. We're going to take 65 pounds and divide it by 2.2. 65 divided by 2.2 equals. You see that? It says 29.545. And when we're calculating a weight, this is kilograms, we're going to keep it at one decimal place, one place after the decimal. That 5 is going to make that 4 a 5. And that this being a 5 would make that a 6. So his weight is going to be 29.6 kilograms. And we're going to keep a decimal place, okay? Now, the order says 30 milligrams per kilogram, just for one. And look how many we got. We got 29.6. So we got to multiply the weight by that, all right? So here we go. Get your calculator, please. Work these with me so that you know what to key in and it's coming up the same, and then you won't be freaking out. So we have to multiply 30 times 29.6 equals. That is going to be 888 milligrams. Look. Well, doo-doo. Come on here. Don't jack with me, dude. I'm doing a slideshow. Y'all bear with me. Slideshow, Dookie. Okay. Hoping it ain't gonna turn by itself. So look, his weight. Sorry about that, but I'm not gonna stop. I'm not starting over. Okay. You see his weight, 29.54 will be 29.6, and then calculate the dose ordered to be 888 milligrams is how much Homer wants the boy to get. So now, we got to calculate how much we're going to get out of the vial. The vial says it's 500 milligrams on the label, and we got to reconstitute it with 5 milliliters of sterile water. So using the information that we have here, we know the dose ordered, or what Homer up here wants, is 888 milligrams given to that child. What we have in our hand is 500 milligrams. To go in this fraction, they have to have the same last name, okay? And how does that come? Well, we're putting 5 milliliters of sterile injection. So by this information, we're going to put 5 milliliters. You see how I tagged their name on there, daggone it? So Ethel put her glasses on and read something. Okay, so this fraction says this divided by that times this. So let's do that in our calculators. 888 divided by 500 equals, times 5 equals 8 point, you see that? 8.88, and that 8 will make that a 9. It's going to be 8.9 milliliters And we can draw that out of a vial. You can draw 8.9 up into a syringe. And so, boom, we saved them. Okay? Now look, if you have messed yourself, your big girl or big boy panties, pause it and go see about yourself. Otherwise, we're moving on. Let's do another one. I know now that you hopefully just get the suck out of your mouth about it. Let's do another one. Ampicillin, 250 milligrams, IV, Q4 hours for infection. The supply is ampicillin, a 1 gram vial, out the gate. Look, you see, you see that's milligrams, and we have a gram vial. So, okay, we're going to have to convert. And the nursing drug reference says reconstitute the vial with 10 milliliters of 0.9% normal saline. And then further dilute in 50 milliliters and infuse over 15 minutes. Okay, take a breath. I know that's janky, but I'm going to explain the janky of it. So first, we don't have a weight, so we've got to find out how much we're going to have to pull out of this vial. Out the gate, you know, 1 gram, we got to convert it to it so it's both milligrams. Or that's what I'm going to do. So look, you could do kilogram, you got kilograms, grams, milligrams, and micrograms. And the vial is at grams, and we're going to go to milligrams. We could make the milligrams, we could go from milligrams to grams, but that's going to put a decimal in there. And a decimal will kill someone. So I'm going to go the route that's going to get rid of any decimals. So we're going to move the decimal. In 1 gram, it's understood to be behind the whole number. We're going this way to the right, and we're going to move it 3 times. 1, 2, 3. I'm going to put my 0 so she don't mark off. If I was going to go from grams to micrograms, I would go 1, 2, 3. I'm at milligrams. 1, 2, 3. Then I'm at micrograms. You move it 3 times every time. And that keeps you from having to remember King Henry and what all he did. So this is our new dose on hand. It's 1,000 milligrams, and we put 10 milliliters in it. So this is the strength that's in our hand. What he wants him to get is 250 milligrams. Let's set up our formula. What we have is 1,000 milligrams per 10 mLs. And we're going to do the math. That divided by that times that. Okay, pay attention. I know you're paying attention, but anyway. 250 divided by 1, 1, 2, 3. Count your zeros, because I do, because I'll jack it up. Times 10 equals 2.5 is how many milliliters we're going to have to draw out of that vial of medicine that we just reconstituted from powder to a liquid. So then we have to take that 2.5. You see it says reconstitute with 10 milliliters of normal saline, and then further dilute in 50 milliliters of normal saline. So how much did we pull out? 2.5. And we're going to put it in a bag of 50 milliliters. So we're going to have to include these 2.5 milliliters. It's going to be 52.5 milliliters will be the total volume for us to calculate it with. Help them, God. He going to help y'all. And so they said we got to figure milliliters per hour. And it's going in over 15 minutes. Goodness. Okay. So to figure milliliters per hour, I'm going to move this up here for a second. It is the total volume over the time in hours. Okay? Our total volume is 52.5 mLs. And the time has to be in hours. And look, it's in minutes. So, 15 minutes. So I always say it like this. I have to tell the problem we're dealing with a 60-minute hour, or else it's going to think it's a 15-minute hour. And so I put it, the total volume times, hey Homer, we're dealing with 60 minutes. Divided by 15, I do all the math on the top and divide it by the number on the bottom. I hope you're just solid rocking right here by me with this. So 52.5. The key thing of the trickiness of this one is you got to remember to add the amount you pulled out of the vial to this bag. People gonna miss it, and you know, if that would have been a patient, they'd have died. But anyway, 52.5 times 60 equals, divided by 15 equals. So 20 in milliliters per hour, it's gonna have to go at 210. Okay, see, we pulled out, I should be better on this, pulled out 2.5. And then to do milliliters per hour, it would be 210 milliliters per hour. And then look, my goodness, she didn't come back wanting you to do drops per minute. The class must have been bad or something. And she just, I'm going to shut up. Okay. So to do drop factor, the formula is the total volume times the drop factor divided by the time in minutes. So if they gave you hours, you need to convert it to minutes. So our total volume is 52.5. And this says calculate the drops per minute with a drop factor of 10. So I'm going to put right here, I'm putting milliliters, and it's a 10 drop factor. And it's going over 15 minutes. Yeah, she's just going to wear you out so bad that you're like, my God, what? We're going to do all the math on the top and divide it by the math on the by the number on the bottom. 52.5 times 10 drop factor equals, don't even look because you're not done. Oh, dookie fart, sorry. I'm going to start over. 52.5 times 10 equals divided by 15. That's going to be 35. Is that what y'all got? Drops per minute. And look, boom. Saved another one. Okay? And some of y'all probably done shut this off. But I hope that you come on and you're going to be like, what? Give me one of those tricky problems Julie's telling me about. All right, look at here. Clindamycin, 0.3 grams IV every 6 hours for infection. What we have is clindamycin, 600 milligrams. Oop, is your butt puckering grams, milligrams? Okay, you know you got to come back to that. But the clindamycin is 600 milligrams per 4 ml vial. And in the nursing reference, it says dilute with 50 milliliters of normal saline and infuse over 15 minutes. So, you're not tricky. You're not tricked by it no more, are you? The first thing we got to do is get these to have the same last name so they could go in our fraction. 0.3 grams. Where's my paper at? Okay, so we're going from grams to milligrams, which means we're going to move that decimal to the right, and it's going to be 3 places. So I'm going to just write it right here, and I'm going to grab it, and I'm going to go 1, 2, 3 milligrams. I really do that on my test, even now, because I don't want to jack it up. A decimal will kill somebody. So what he wants them to get is 300 milligrams. What I have in my hand is 600 milligrams per 4 milliliters. 600 milligrams per 4 mLs. And we're going to do the math. This divided by that times that. So grab your handy dandy calculator. Let's do it together. 300 divided by 600 equals. And then, oh wait, times 4. So we're going to have to draw 2 milliliters out of the vial. Boom. You see that? I know it's a lot, but just take one question at a time. So now it says to calculate the milliliters per hour to set the IV. Now it said once we get the medicine that he wants for this dose, we have to put it in 50 milliliters of normal saline. So now it's going to be 50 milliliters plus this little 2 we got with the concoction in there. Concoction, what I said. Okay. And they want milliliters per hour, and it's going at 15 minutes. We're going to do the same thing. 52 until the problem that we're dealing with 60 minutes. Put ml so Ethel knows. And then 15 minutes. We're going to do all the math on the top and divide it by the number on the bottom. So here we go. Get your handy dandy calculator. 52 times 60 equals. Divided by 15 equals. So we're going to have to set that pump at 208 milliliters an hour. Look. Boom. You know. And then, look, she wants you to do the same thing with the dad blame drops per minute. So I'm going to just do it right over here. So drops per minute, remember our total volume was 52. 52 milliliters times the drop factor, which they want at 15 drop factor. I put that so Ethel knows. Divided by 15 minutes. The time has to be in minutes. Thank goodness it was. And we're going to do that times that divided by that. 52 times 15 equals. Divided by 15 equals. That's going to be 52 drops. Let me read it. Oh, yeah, 52, because those cancel out, really. And I'm sure somebody on here will say that you just cancel out. If I start marking lines, I'm going to jack it up, and I know myself. So, look, we saved them, though. Boom. Saved another one. Okay, yeah, I got another one, because I want it to be like, what, girl? Give me that. Let me work that for you. Vancomycin, 1 gram, IV piggyback every 12 hours for MRSA. Put your gloves on. The supply is vancomycin, 1 gram vial. And the nursing drug reference says reconstitute each 1 gram vial with 20 milliliters of sterile water. And further dilute in 100 milliliters of normal saline to infuse it over 60 minutes. So the vancomycin comes to you in a powder. And then we got to add 20 milliliters just to get it, you know, in a form that we can give it. And then once you put the fluid in, then that is a 1 gram vial per 20 milliliters. And what he wants is 1 gram. So isn't that sweet? So let's just work it because we can. And look, Ethel may want you to show your work. So he wants him to get 1 gram. And what I have is 1 gram per 20 milliliters. So that divided by that, let's do it. Look, 1 divided by 1 equals 1 times 20 equals 20. So we're going to draw 20 milliliters every single drop out of that sucker, because that's what the doctor wants. And then we have to take those 20 milliliters and inject it into one of them little 100 milliliter bags of normal saline. And so 100 plus we add this 20 milliliters with the good stuff. That means the total volume is going to be 120 milliliters. Help them, Lord. And then you got to calculate the milliliters per hour. And it's going over 1 hour. So you remember the milliliters per hour, the total volume, divided by the time in hours. So if we have 120 milliliters, and it has to go in over 1 hour, then let's do the math. That divided by that, 120 divided by 1 equals, it's got to go at 120 milliliters an hour. That was sweet of her. Hopefully everybody got that. It's got to go at 120 milliliters an hour. And then, of course, she's just going to throw another drop factor in there because she can. And so we're going to do, the drop factor is 120 milliliters times a 20 drop factor divided by 1 hour. And the time has to be in minutes. Burn that into your frontal lobe. 60 minutes. It has to be in minutes on the drop factor. So we're going to do all the math on the top. That times that and divide it by that. Here we go. Like Olympic gold medalists from the old country. We're going to do it. Divided by 60. And that will equal 40 drops per minute. Come on. I did it wrong. Hold on. I did 120 times 20 equals, I was talking. Okay, that's right. I put 34. What the crap was I thinking? 120. Okay. It's 40. You see that? I'm going to work one more time. 120 times 20 equals, divided by 60. 40 drops per minute. I'm going to do, is this the last one? Oh, don't look. Okay. If you burn out, push pause and drink some orange juice. So Zantac, 50 milligrams IM every 6 hours for ulcers. The Zantac supply is 25 milligrams per milliliter vial. And the Nurse and Drug Reference says to dilute it with 50 milliliters of normal saline and infuse over 30 minutes. So the Zantac, what he wants is for them to get 50 milligrams. What we have is a vial that the strength of it is 25 milligrams per 1 ml. And we're going to do this math and see how much we got to pull out of the vial. That divided by that times that. 50 divided by 25 equals, times 1 equals. We got to draw two what? Whatever you tagged on right there. 2 milliliters. That's why you put their last name too, besides Ethel. So how many milliliters will you draw from that vial? 2. Sure enough will. And then we got to how many milliliters an hour? We have 2. We got to add to that 50. Just don't forget that. So the total volume would be 2 milliliters. And they want it over 30 minutes. So you know what you need to do. Tell your problem. We dealing with 60 minutes. And then put 30 minutes on the bottom. Now, there are some people who are going to put on here, you could do 0.5. You could, but once again, there's a decimal. And decimals kill somebody. I mean, you may be much more versed in that kind of math, but that's not necessarily my gift, but 52 times 60 divided by 30 times 60 equals, don't look at it, you're not done, divided by 30 equals 104. We're going to have to set the pump at 104 milliliters per hour. Look, boom. We saved them. And of course, now we got to do the drops per minute if it was a 10. So we're going to take our total volume, 52 milliliters. You can do this now. Times the drop factor, 10 drop factor. And if you know me, you know I got a fear of fractions. Some people will put the drop factor over here in another fraction. If you do that, I don't know whether I cross multiply or find a common denominator. I mean, I fret about it. And so I just quit doing it. And this works. The drop factor, and then over 30 minutes. I hope y'all hanging in here. And we're doing all the math. That times that divided by that. 52 times 10 equals. Divided by 30 equals. And that's going to be 17.3. You cannot give 0.3 of a drop, so that would remain 17 drops per minute. Look at there. Boom. We saved another one. I hope it helps. All right, marinate on that. Y'all have a good one. Please like and share. Comment. Share it with everybody. Everybody, please. Thank you.